Hey guys, Mr. Johnny here. The videos that I'm about to edit together, I'm gonna just say this straight away. It ain't gonna make much sense because it's gonna skip all over the place. That is because that repair, these kind of speakers, they took me ages, absolute ages to repair because of various reasons. So one piece of footage I was talking about one scene, then the next footage was shot quite a lot after, and I kind of forgot what I was talking about in the previous part, so well, pardon my French, I guess. Hi guys, Mr. Johnny here. In this video I'm gonna continue to work on these speakers, and yeah, I've did some things to it, so let me explain what I've done. First of all, I went and tried to swap the chips around, as one of you suggested, namely my very keen viewer from Great Britain, hold on there, ZX841ZTV. He suggested to go and swap the chips around, which is exactly what I did. You can see the chip with a slanted edge or chamfered edge is there now on the left. Previously it was here. I just swapped them around, and I'm gonna test them actually. I soldered those two resistors in, and everything is soldered in. I also found some bad capacitors, which are bad not ESR wise but leakage wise. I'm gonna show you them later. They were these two, this one and this one. They are in the feedback. I decided that that would solve it, because when I just swapped them around it made no difference. Now I replace these bad capacitors, these two, and it again doesn't make a difference, even when I use the same speaker. This one. That's why you can see a wire going there. One end is soldered to the ground there. Other end I'm gonna attach to one amplifier and then to the other amplifier. I'll explain you why. I will explain why I do this instead of using this speaker a little bit later. Hold on. So first thing, I plug it in. It goes poof. I go and do this. Basically touch left and right inputs. And now it's gonna be this chip and this speaker, of course. The chip which was weak before, and now the chip which was, oh sorry, that I flipped it around and forgot about it. This is what the strong chip was, and the weak chip is still weaker. Strong, weak. It is still weak, even though I changed. Plus this chip gets blistering hot now. What the is going on there, huh? It should not do that. I've done amplifiers on these chips before. They should stay stone cold pretty much. This chip is a strong one, but it freaking heats up a lot. And that's the one which was heating up before. That's the one with this right edge, see? Not chamfered edge. Previously it was there, as you remember, and it was heating up there too. Not as much, but it did. This chip, being located there, did not heat at all, while this one was heating up here, and now it heats even more here, which was, yeah, so these chips have to go. This chip is seriously damaged for some reason. I tested the RC Zobel networks there, which you can see this green cap and it 10. It's a 1 ohm resistor, as you can see there, and these green caps. In case you did not catch it, this resistor, this cap, this cap, this resistor. RC Zobel networks are alright. So the chips should not oscillate, it should dampen the oscillation and everything should be fine. Yet this chip still manages to heat up like a bastard. So yeah, in case you want to accuse me for replacing this for no reason, first of all, they are different. It's a big no-no. Preferably you should even get ones from the same manufacturer, and even better yet from the same batch. So yeah, this chip has to go, definitely. And this chip as well. Plus they are inexpensive, I'm gonna replace them anyway. And let me now explain why I did not use this speaker at all. Because that's a wire cable which is used to connect it. RCAs and this kind of thin flex which did not really instill much confidence in me straight away, and for a reason. That reason is when I'm gonna do a little test on my power supply. I'm gonna show you right now. Here is the cable, as you can see, right there. That's a radio humming in the background, playing my music that I transmit myself from a laptop. It's pretty convenient. I'm gonna make a video about that receiver, about that radio sometime. But anyway, what I'm gonna do is I'm gonna use my bench power supply. I'm gonna set 0.5 amp constant current limit, and I'm gonna see how much drop will be across this cable. Thus I'm gonna know how good this cable is. How big is it? How big is its resistance? Okay, leads connected just from the power supply. You can see about 0.5 amp and 0. So the leads here are nice. You can see 0 volts there. It's about 40 millivolts if you're that curious. And you can see now they are clipped right there on the ends. See? 3.4 volts at 0.5 amp. So the resistance is twice that. It's not 3.2, it's 6.4. 6.4 ohms. 6.4 ohms, my friend. And that's only one wire, the central one. If we flip it to the shield, we see 6 ohms too. So it's like 12 ohms loss in the resistance of the cable, and that is when the resistance of the speaker, the impedance, sorry, is 8 ohms. So it's a 16 ohm resistor in series with an 8 ohm resistor. Will you receive the maximum power on that 8 ohm load? Hell no, you won't. Speaking of capacitors, here are those two I desoldered from the board. 10 microfarad, 25 volts. It's looking at one, 11.22, so it's leaky. 3.9 ohms and 3% V loss. And that's the other one, 2.7 ohm percent, sorry. 12.7 microfarads. Bad. Very bad. And to top it off, that's an input cable, right? You can see a 3.5mm jack there, so that's the input. It should not handle large current. Same test, as you can see. And look at this. 0. Isn't it ridiculous? You put a crappy cable on the output, but a good one on the input, where there's pretty much bugger all current is flowing. What the hell? Alright guys, parts are in. Here you can see a couple of chips and 3 potentiometers, which are not what I wanted. I'll show you why shortly. So the chips are here. Focus. There we go, you can see them. They are from Unisonic Technologies. And the pot looks like a dual potentiometer until you do this. Then you will say, what the hell? Well, just listen. What the I did not tell you that, but all pots on that speaker are scratchy, so they gotta go. Well guys, I'm a blind ass, because they did say in the listing that this thing is with a switch, it's not a dual potentiometer. Well, at least let's go and solder in those chips, see if none of them will heat up. And why use solder wick if I can use a cheap ass method for that? Just heat up the solder and poke a hole in it with a toothpick. By the way, there is a little black mark right there. So I guess one time the chip went bang there. Okay, I took the heatsink off just so I can feel the chips. That's a smoke test, it will be right now. First, power up. I heard a little pop in the speaker, so yeah, that's fine. Let's get the input cable. I still have to do something, by the way, with this output cable, which is more like a input cable cross-section wise. It is so ridiculous. Oh, of course, look at that. That was used to connect the speaker to the amplifier. That is ridiculous. Okay, to make myself feel a little bit better, I'm gonna go desolder this volume control potentiometer and measure it. Why it should make me feel better? Well, I'm gonna feel better if my hunch about the uneven wear on the tracks is a difference, is what creates a difference in volume on channels. Okay, the pot is desoldered. Let's focus about here. About 48K. 44K. Oh yeah, there is something going on. Yes. Okay, again, I went and not this time purchased the right part, so here it is. There was here in this speaker B50 case I installed. B stands for linear taper. This one has A, which is logarithmic, which is the type that is preferred for audio. I do not know why did they use linear ones there, but regardless. It changed the situation a little bit. You may see a wooden piece here. I will show you that later. What the hell is that? So, but for a moment, let me make sure that the phone ain't gonna fall. So I'm just gonna go and you can see the board is undone. One potentiometer is already taken off. This piece was ground in the cases together. If you are building your own amplifier and you do not do this, it will hum and pick up all the other crap, so do that. It is a must, really. Okay, as you can see, the ICs are new ICs are installed, same type, TDA 2030A. DA2030AL actually, from UTC. These do not heat up as much, but they still do heat up quite considerably, which is actually normal because it's freaking fridge. Because it's a Class AB amplifier and it has some quiescent current, a current that it consumes, a current that flows through the output stage even when no signal is applied at all. Desolder, solder. For that I'm gonna use this type of a tip. Soldering station on. Why do I use this tip? Because it's awesome for it. It is quite large, so I can heat up two pins at the same time. And the bastard, if you can see right there, this is bent over and pretty much laying flat on the board. So, and this board is very shite. The pads lift very easy. Crappy, total crap. Another advantage of this tip is it has pretty large surface, so you can clean up holes like this. See, it cleared up. And I'll just go use. I use this. Oh boy, use this thing instead of a wet sponge. I'm getting sick. And for the cases I'm gonna use this bevel tip, because this thing kicks ass when it comes to high thermal mass. Soldering components that have big thermal mass. Okay, it's hot already. I love this soldering station, you know. Oh boy, put it in focus. Let me grab some sandpaper. Okay. I'm gonna be a savage and put the solder blob right on this WL. Ay. Okay. I'm gonna use additional flux. The flux in this solder is adequate for the job, if you ask me. It's a 1mm solder, by the way. It is quite, you know, see, lives its own life. Ay, hot stuff's hot. That's what tweezers are for, you moron. And I always get myself in these stupid situations where I have the tweezers sitting like on a bench, you know, within an arm's reach, and I always use my fingers and burn them and stuff like that. It just gets nasty. Okay, everything is soldered in. Board is cleaned, as you can see. Not perfectly clean, but much cleaner than it was. That's alright. Had to do a little mockery there. Right there. Piece of little cut off lead from a resistor to double up the track because the pad was lifted and I could not trust it. This pad is lifted as well, you can see track, but that's alright there. That won't break because it has a nice little bend there. Plus that component does not move at all. So, and as you can see, I relocated this wire from the bottom side. I took off that connector and soldered it right in. Now all that's left to do is to hook up the power. And fix up that crappy cord, and that will be that. I'm using this heatsink compound, which I bought very cheaply from locally, but it was obviously from China. It has some kind of metal powder, as you can see, because it's a silverish color, and it's suspended in the silicone grease kinda, and it has a tendency to you know, separate. so a little bit of pure silicon comes out, so I like to do squish out a little bit, check it. Okay, it's not completely, you know, not a pure silicon grease, so we can go and use that. Some people just put a little blob in the middle and that's that. I like to just spread it around a little bit. I never had the problem with that. Even on such pesky devices like computers, CPUs and stuff, you know. But you see what I've done there? I spreaded it and I still put a little bead in the middle, so it will squish out. Oh crap, this capacitor is a bit in a way, but so let's start off with this part. Yeah, flathead screwdriver on a Phillips screw. You're watching Mr. Johnny, nonetheless, you know. You should expect this kind of stuff already. Now let me get it. Phillips. Because Phillips is not so pesky, you can tighten the screw at a little bit of angle. It will still work somewhat. I will just go and run it down as much as I can. And here I'm just gonna use a redneck method. Trying to compress the video. And sometimes, you know, knobs go pretty loose on these potentiometers. That's why you see them using a bit of tape there to shim it up and to stick it. It's not so much sticky on this side, so it's really a shim. What I like to do is to go and put something like a wedge shaped, something just wedge these two pieces apart a little bit, but be careful. You saw how that stabilizer post broke off easily, so do not let that happen to you with this. And yes, I don't like how the mains flex is done there. Okay, redone. As you can see right there. God damn it, this. You can see it's changed. Heat shrunk, and there is a little fuse, 2M fuse. It's the smallest value I could find, only one. So, god damn it. Okay, I figured out what to do with that cable. You can see this cable here, 0.34 square millimeters. Not the thickest one, but you know it will do. It's much better than what it was before. I now switch to only one jack. You can see that one is hardwired into the speaker, because only one jack survived being taken apart, the other one disintegrated in my hands. Plug it in there and give you a demo. For the demo I'm gonna use this phone, which is my old phone, J5. The phone I'm holding right now looks exactly like this one, but a little bit bigger, and has a little bit more powerful hardware. I'll turn it on. Switch. Stupid jack here. If you mumble with it, it thinks that you press the button. I'm gonna muck around with the bass control. Here. So that works. Now treble. And that works. And the volume, of course. Which works just fine. So that's it. It is successfully repaired. I don't know. I do not feel all that great about running the ICs at 40 volts because they are rated for 44 maximum, but we'll see. Again, luckily the power supply sags down whenever you load it, so that should be fine. Thanks for watching. See you.